Hi there. In this lecture, you will learn about the important concept of the customer order decoupling point and how it relates to 4 distinct production strategies, namely engineer to order, make to order, assemble to order, and make to stock. One important aspect of how firms decide to compete is where they decide to place the market penetration point, also known as the customer order decoupling point. The customer order decoupling point separates order-driven activities from forecast-driven activities. Let me explain. Consider an axis from raw materials to consumption. If you are a manufacturer, where would you store your materials? Perhaps you want to first buy materials when you have an order. Maybe you want to store some materials as raw materials, perhaps as components, or even finished goods. This is a very strategic decision with great impact on your operation system. If you store most of your products as finished goods, you follow a make-to-stock strategy. When customers put in an order, you simply pick from inventory and ship it to them. It means that your customer order decoupling point is at the finished goods inventory. If you store your products as assembly-ready components, you follow an assembly-to-order strategy. Whenever a customer orders a product, you pick from your inventory of components and put them together in the configuration the customer wanted, then ship it. The customer order decoupling point is then at the final assembly. If you store your materials as raw materials, you follow a make-to-order strategy. Whenever a customer puts in an order, you take out materials, start to manufacture, and assemble them into final products. The customer order decoupling point is then at the fabrication stage. But sometimes, you first start designing the product after getting an order from the customer. We then call it engineer to order. This is the extreme case, in which you often may carry no inventory or just bulk inventory of standard components like steel, chemicals, nuts and bolts. The customer order decoupling point is then at the design stage. So let's recap. Before the customer order decoupling points, your activities are driven by your forecasts. After the customer order decoupling point, your activities are driven by the order of the customer. The 4 production strategies, engineer to order, make to order, assemble to order, and make to stock, can be derived from this. Note, of course, that these are generic strategies and most companies will use a mix of them. Okay, enough theory. Let's go and visit a few companies. Wow! Take a look at this. This is a photo from an oil platform manufacturer we work with. What kind of production strategy do you think this company uses? Correct. Engineer to order. In this business, you really don't want to stock up on all the expensive, heavy, and many products you need to make it. Actually, in this industry, you start to design the product when the customer asks for a bid. And what about aircraft manufacturers like Airbus and Boeing? Correct. Their production strategies are make to order. What about computer manufacturers like Dell? Actually, Dell follows an assemble to order strategy. They wait for your order to be placed before they take pre-produced parts and put them together into your specific product. This is a strategy also known as mass customization. Other laptop manufacturers may follow a make-to-stock strategy, producing standard computers that they're selling in the retail market. Finally, let's consider typical consumer products like diapers. How long do you think parents are willing to wait if their baby is just about to themselves? Not long. That's why most of these products are made in a make-to-stock fashion. Actually, most of the products we consume in this world follow this make-to-stock strategy. When you do, you better make sure you're good at forecasting. These examples reveal some fundamental insights about the different production strategies. Where you place your customer order decoupling point is a strategic decision that affects your effectiveness and efficiency. If you have long process lead times or bad process control, meaning you're making faulty products, you must consider putting your customer order decoupling point closer to the customer. Why? Because customers are generally not willing to wait long for their products, and if you make errors, you need additional time and resources for quality control and repair. Then, storing products as final goods create the buffer needed to sort out your long and variable internal processes. Of course, in cases where the customer requires immediate or fast delivery, or you need to be very sure you have the product on stock whenever the customer wants it, you also have to move the customer order decoupling point downstream towards the customer. IKEA, for example, is a typical make-to-stock manufacturer. On the other hand, if you have irregular demand or highly customized products, storing finished goods is a very risky and expensive strategy. It can also be that you, for different reasons, do not want to hold stocks of finished goods. For example, if your products are fresh goods or quickly expire, you should not stock more than you know will be sold. Recall HelloFresh? Same for technology products that risk becoming outdated and obsolete as the technology development rages on. Also, if you have very expensive, fragile or large products, you would probably not like to hold large amounts of finished goods. In these cases, you would move the customer order decoupling point upstream towards raw materials. If you move the customer order decoupling point downstream towards the customer, we can also call that strategy speculation. You speculate that you will be able to sell what you produce. In this case, you better be good on forecasting. Speculation also has advantages. Make-to-stock manufacturers often enjoy economy of scale, which makes each individual unit cheaper to produce. Other advantages are of course faster lead times and minimized risks of stockout. If you move the customer order decoupling point upstream, we can call that strategy postponement. In this case, the company postpones the decision to do something with the material before they have certainty in a customer order. The result is lower inventory holding cost, minimized risk of dead stock and obsolescence, but it also creates much longer lead times. Can you take one more concept? Here is the T-point. It is not named after me, but the fact that many manufacturers have one or several specific points in their production processes where the number of product variants goes from few to many. The T-point demarks this variation explosion point. For example, if you're printing customized t-shirts like Spreadshirt, the T-point is in the printing process. If you're mass customizing office chairs, the T-point would be in your assembly line. Note that the T-point is usually a good candidate for placing the customer order decoupling point. So, in this lecture, you learned about the customer order decoupling point and the 4 generic production strategies: engineer to order, make to order, assemble to order, and make to stock. You also learned about the speculation and postponement strategies and the simple concept of the T-point, which affects where you should put the customer order decoupling point in your production system. See you next time.